So the last screencast for the nomenclature unit deals with objective number 8, defining the laws of multiple proportions and the laws of definite composition, also sometimes called definite proportions. These two laws are very similar to each other, and they can be very confusing when you're trying to decipher between them, but hopefully in the next few minutes you guys understand the differences between them. These laws were actually developed by Dalton when he was developing his atomic theory. So they are part of the 6 parts to Dalton's atomic theory. These are 2 of them that have since turned into laws that govern chemistry and pretty much everything we know about chemical compounds. So the first law is the law of multiple proportions. In class, we are going to read page 76. We're going to read paragraphs 1 through 3. And we're going to look at the figure and we're going to answer this question. And then we're going to watch the video clip. But I'm just going to kind of explain to you. So you don't need to write any of this stuff down. I would write this stuff down. The law of multiple proportions just simply says you can form different compounds by combining the same elements in different ratios. Different compounds, different properties. This is how you can take like carbon monoxide and carbon dioxide, which both have carbon and oxygen in them, but they've combined in different ratios to form different compounds. I've given you the example here of water and hydrogen peroxide. 2 very different compounds with very different properties. One of them, sustains life. One of them is actually poisonous. But you notice they both have hydrogen and they both have oxygen in them. They're just in different proportions, or they're in different amounts. And that's where the multiple proportions comes from. They're in different ratios. This isn't a 2-to-1 ratio of hydrogen to oxygen. This isn't a 1-to-1 ratio of hydrogen to oxygen. So by just combining them in different amounts, I can get different formulas. Now this doesn't work so well for an ionic compound, because in ionic compounds you balance charges. This is really only possible for molecular compounds where you don't balance charges. The next law, again, or law of definite composition, or the law of definite proportions, we're going to read page 75. We're going to answer the question. We're going to read the history about Lavoisier. And then here is the stuff that you need to write down for this. The law of definite composition just simply states that a specific compound is always composed of the same elements in the same proportion by mass. Each compound has its own formula, and that doesn't change. What this is simply saying is that water is always H2O. So when I write hydrogen and oxygen in different proportions, like on the previous slide, like this, water and hydrogen peroxide, this is always water. Water is never anything else. This is always hydrogen peroxide. It's never anything else. So each compound has its own formula, and that does not change. So water is always H2O. It's never any other ratio of H and O. Can I make other compounds with those other ratios? Yes. I can take and make H2O2, but that is not water. Once I change the ratio, I change the compound, I change the properties, and I no longer have water. Just like with carbon dioxide and carbon monoxide. They both have carbon and oxygen in them, but one is CO in a 1-to-1 ratio, and one is CO2 in a 1-to-2 ratio. And so because you've changed the ratio, you've changed the compound. So multiple proportion says we can change the ratio, but the law of definite composition states that each one of those is uniquely its own compound, and it will never be anything else. So there's this video that we are going to watch together in class after we do our readings. I'll go ahead and cover objective 9 and 10 here, but you will not have to do anything with these. These are strictly going to be done in class. You're going to make concept maps on how to name all the chemical formulas, or how to name all the chemical compounds, and you're going to make a concept map on how to write the formulas for them. So just kind of the rules, that's going to be like a flow chart that you can follow to guide you through what compound you have and what the particular naming rules are. And you're going to do all of this in class.